4530 number of good leaf nodes pair, right? So in this question, what we have to do, we have to find the number of pair between child nodes whose distance is less than 3. If we take the example, first example, so we have two child nodes, 4 and 3. So we have to first identify the distance between them, the shortest distance. So it's actually 1 unit, 2 unit, 3 unit. So it's 3. And what distance is given? The distance is given 3. So we have to find all the pairs of the leaf, right, where the distance is less than 3. If we take the example, second example, right, this is we have 4, 5, 6, 7. There are 4 leaf nodes. There are 4 leaf nodes and the distance is given as 3. So we have to find all those pair of leaf nodes where the distance is less than 3. If we take the example of 5 and 6, and if we try to calculate the distance, it's 1 unit, 2 unit, 3 unit, 4 unit, right? So 5 and 6 cannot be a pair. So we just have to find those pairs where the distance is less than or equals to 3. So there are only 2 pairs, 4 and 5, because the distance is 2, which is less than 3. And similarly 6 and 7. If we try to take 4 and 6, it won't work because the distance is greater than 3. It's 1, 2, 3, 4, so on. So the first thing that comes to our mind, that because we just saw it 2 days back, right? We can calculate the distance between any two nodes. Shortest distance between any two nodes is nothing but the distance from its common LCA, right? If we have to calculate the distance between 5 and 6, it's 5 and 6, right? So their common ancestor is nothing but 1. So the distance has to be calculated from 1. Then we have to calculate the distance from the root to child, and then we'll add the distance. That's how we get the distance. So if we try to apply that same logic here itself, we first have to identify all the child nodes. Then we have to calculate for each pair, for each possible pair, their LCA. And then we have to calculate the distance, and then we have to compare, and then we'll add it to our result. So it will be a very time-consuming process. So instead, what we'll do, at the time when we encounter a child, right? So the child distance from itself is nothing but 0. So we'll assign the distance to a 0. And moreover, what we'll do, for each node, right? For each node, we'll have an array. For each node, we will have an array that will store the distances, the counts of nodes that are present, their distance. Let's show with an example. Let's start from the leaf node itself. So at 4, since they are going, there is no further node attached to it, right? It's a leaf node. So from the leaf node to the leaf node, the distance is 0. So for all the leaf, we'll make the distance 0. For all the leaf, we'll make the distance 0. So how we'll do it? And each node, right? For each node, to store the distances, we'll take a array, right? Let's name it the distance array, maybe. And its size will be 11. Because why 11? Because it's given in the question, right? The distance can be only till 10. So 1 to 10, we have to store distance 1 to 10. And how many nodes are present? So we'll take a array distance of 11 to store 1 to 10 value. And this will store, right? It will have something. This will store at each node, right? For each node, let's say at 2, it will store the number of leaf node, right? The number of leaf node at what distance? Assume distance, right? 11 is something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Not 11 actually. We'll store from 1 to 10 only. So for the 0 index, we don't have to consider anything. We will only do the iteration from 1 to 10. Okay, from 1 place to 10 place. So 1 place and 10 place shows nothing but the, let's say at Okay, let's do the indexing also. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How come? 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's done. I think I will do one more. Alright, this will be index. So what it actually represent, at each node will assign this, right? We'll create a new array for each node. And this will represent like at if the at 2 place, right? Whatever value will have. So it will represent, like let's say make it 4. So at this node, whichever node it has been assigned to, there are 4 leaf nodes at a distance of 2. Right, this will show the index will show nothing but the distance, and this will show the count. So there are 4 leaf nodes in the, if we check for the first place, right, it has 1 and 2, 1 and 2, 1 and 2, and 1 and 2. So all the 4 leaf nodes are at a distance of 2. So in place of 2 it will have 4, and the rest, right, and the rest places it will have 0. So what it actually shows that certain node where we are standing, it has 4 leaf nodes at a distance of 2, right? So that's what we need if we want to calculate anything, right? What we have to calculate, how many is the, what's the shortest distance, the pair, right? The number of pairs. So it actually shows there are 4 nodes which are at distance of 2, right? And right, okay, let's start coding it, so we'll have a better idea. So this is what something with this concept what we are going to use in this question, so that we don't have to do those things, right? So I'll take a, let's say I'll take a global variable count. Okay, now we'll do the reversing. So we'll pass, okay, we have to initially the count will be 0, because right now we don't have any good pair. And we'll try to see DFS, root, distance is important. Alright, that's all. And we'll return the count, whatever count this function has returned. Okay, so normal DFS, we'll start and we'll keep on modifying it. So private, static, let's say, right now it's white, but we'll change it. And DFS, node, root, and distance. Okay, so if root is null, so right, we have reached somewhere at the very end, and what we have to do. In that scenario, it's like the distance from the leaf, it doesn't make any sense, right? So we just have to return null in that scenario. So we return, what will return? We'll return new end, because what we thought, right, we'll assign each node, right? Each node has to, every time we call this function, it actually has to return a integer array, right? So we'll make it an integer array, and that will be nothing but our distance, and it has size has to be 11. So in short, it has returned an integer array of size 11, and each way, because we have initialized this is a default, it will have a 0 value, because the distance from the null, makes no sense. The distance has to be 0 because there is no child element. It's a null place, right? So, but if the root dot left is equals to null and root dot right is equals to null, so what it shows? It shows it's a root element, or not root, it's a leaf node, right? So what we had discussed, right, from the leaf node, the distance from the leaf node to itself is 1, right? It's going to be 1. So again, we'll create it has to return again, right, the distance. Distance equals to new end 11, and then we'll assign, because the distance is 1. So at first index, right? At first index, we have to assign the value 1 for this node. So distance dot 1 will be 1, and this will return the distance if it's a leaf node. All right. If it's not a leaf node, then what we'll do? We'll try to call for the left one and for the right one. So enter left distance, and we'll call sim DFS for the left one, and similarly for the right one. So root dot left and row, let's name it as right distance. Alright, so this will return some to these two arrays. Now what we have to do, we have to see. Assume we are standing at 2. Okay, we are standing at 2, and this has returned what? Because it was a leaf node, it has returned this array, correct? Where the first place is having 1, and this has returned also one array where the distance is equals to 1, right? They have written those things. In that scenario, how can we assign an array that will represent the distance for this node, right? So we first have to iterate on both of them, right, to get the values. So for what we'll do, int I equals to, no, not from 1, because, right, in I plus plus, and similarly, and j equals to 1, j less than equals to 1, and j plus plus. Right, so this is nothing but the distance, correct? This is nothing but the distance. And we have to see if I plus j, if it's less than or equals to distance, right? Because I is going to be 1, 2, 3, 4, 11 till 10, and then 1, 2, 3, 4. So we have to see for all which pairs it is possible to have the distance, right? So we'll do what we'll do, I plus j, because if you remember, right, in this index, the values are actually the count of the leaf nodes, but the indexes are actually the distance. So we have to see if adding those distance is less than or equals to is the actual distance, right? Better to rename it something. What should we rename it? Let's rename it to count of leaf node, a count of leaf nodes. Okay. So if this is the case, right? So in this certain, for in node 2, right? It got like one from this side, right? For those two, it will have some possible values, but we have to calculate the pair. So how many pairs is going to have? Let's say it had returned something like three leaf nodes. It has returned 2 leaf nodes. So if we try to see all the possible pairs it could possibly form, right? From the left side, if we got 3, and from the right we got 2, 3 leaf nodes. Let's say 1, 2, 3. And from this side, 2 leaf nodes, which is, let's say, 5 and 6, 4 and 5. So pair will be like 1, 4, 1, 5, 2, 4, 2, 5, 3, 4. It's just we have to multiply those to get the count of number of pair, right? So we'll add after multiplying it, we'll add them to the count. All right. So we have to get the values, and then we have to just multiply them and store them into the count variable. So we will get the values from the leaf, how many leaf node is present at that index and that distance, and similarly from the right, how many is present. So it will update our count. Now what we have to do, that's how we'll update our count. But at the same time, now the time we have updated the count, we got our leaf node and left node. Now we are standing at some certain node, and then at that time we have to assign, we told, right, for each node we'll assign an array, right? So we'll create an array like current node count goes to again 11, and this has to be assigned, right? So we'll iterate on it, I less than 11, I plus plus. All right, and it has to be attached. Since one thing to understand, till here the distance was 1, right? Because it was a leaf node. So during the leaf node, we assigned the value 1 because at index 1 because the distance was 1. Now that it has been called from this one, right? We are going like backtracking, right? We reach the node and then it will return from the DFS. It will start from root, went to left. It got the leaf, returned some values, right? So it got 1, and the moment we are assigning it for this one, right? The distance will increase. So now that what will store not in the place of I, will store in the place of +1, right? So we won't store the values because the distance has increased by 1. So we'll store it 1 plus 1. The next index, because index actually represents the distance, right? And right, how many count? So similarly, let's say this has returned 4 at distance 1. This has returned 5 at distance 1. So from this place, if you try to see, so 4 plus 5, 9, right? It has 9 leaf nodes at a distance 2. So I have increased the index, and just we have to count add the values, right? I plus from the left one. I. And it should be done. And then just return it. It will be assigned to the node itself. And if you try to run it, alright. Let's say on double equal single, right? Non-static variable count cannot be rendered from a static context. Okay, we cannot make it static, right? Static cannot call it. It should be fine. Okay, array out of index 11, right? It's also 11. It is going less than 11. Okay, no point of going till the very end, right? We just have to see till the distance, right? How many is there, and then let's assume like we created an 11, right? Because till max it can go up to 11 the distance. But let's say for the question 1 it's given till 3. So this array, right, which we created, although we did create it for 11 to satisfy all the test cases, but in reality, let's say 0, 0, 0, 0, 0, 0, till 0th index, 0th index, first index, second index, third index, 4 index. So this is the become distance 4. So we are not concerned with this part, right? We just have to see till here how much we got and act on it, right? So we don't have to actually iterate till the very end when we are assigning for the current node. We just have to iterate till the distance. And if we do so, then that should be not the case. Okay, this right, we have to taking it down. Okay. Okay, what went down? Oh, sorry, here also we are iterating till the very end. That was a mistake. Only time at the time of declaration it has to be 11, but we don't have to iterate till the very end. We just have to iterate till the distance. Okay, so we'll just modify it. Not till 11. Whatever value is given. Still, it's not giving the correct result. Where we went wrong. Okay, it's a leaf node. We created the array. We assigned value 1 at index 1 and returned it. Perfect. We count for the left and we count for the right. And then we started increasing the count. Okay, based upon the result. Right, I from y2 distance, perfect. J to distance. Y plus j less than distance, combine current equals to leaf node I. Okay, it has to multiply, right? We have to multiply because that many pairs will get, right? Oh yeah, it's done. Let's try to submit it and see. Works perfectly fine. So it's a bit tricky. Even I was not able to come up with the solution. I had to see how it can be done. So it's not pretty intuitive. But the trick part was something like at each node, this is the crux of it. At each node will assign a array to it, whatever, because the limit is 10 here, right? So the max distance it can have, it's 10. And each indexes represents the distance, and the value will represent the count of leaf nodes from it, right? So if we try to see for first, right, it will have 11 size array, and at index 1, index 2, index 3, it will have 0. But at index 4, it will have, at index 2, 1, 2, 1, 2, 1, 2, 1, 2, because all the 4 leaf nodes are at distance 2. So at 2, it will have 4 value. And if we try to see for the root 1, right, the value is actually node 1. The array, right, the array that we have, 11 size array, it will have 0, 0, 4, and rest of the value is 0, 0, 0, 0, 0, 0. So what it actually represents from this node, it actually has 4 child nodes, 4 leaf nodes, who is at distance 2. This is what we are calculating. If we have this one, then our job is pretty straightforward. Once we have the count, then we can easily see, right? Because we have to only check for the distance is less than 3. Even if it has something like here, let's say it has 7, if we don't bother it, right? We don't have to check for these part, because our answer needs to be under 3. So we'll only check till index 3. Till here, what is the count of leaf nodes? Assume, let's say it had something like 1 here and 2 here, right? So it represents that it has 1 leaf node at a distance 1, 4 leaf node at a distance 2, and 2 leaf node at distance 3. That's what it represents. And from this, how many pair we can make? So it's pretty straightforward. We just have to multiply, right? Because we just saw if we have 1, 2, 3, and we have 4, 5, these many we have, right? So the pair will be 1, 4, 2, 4, 3, 4, then 2, 4, 2, 5, and 3, 4, 3, 5. So it's nothing but we just have to multiply the count. It's in total count is 3, and total count is 2. So 3 to 6. So 6 pairs. Eventually we got 6 pair only, right? 1, 2, 3, and 1, 2, 3. So we got 6 pair only, right? 4 will pair with every 3, so it will give us 3 pair, and 5 will pair with every 3, it will give 3 pairs. So eventually we get 3 pairs. So we just have to multiply. So that's what we did, and we just add to our count, right? And this is how we are assigning, because every time we are assigning, we have to assign it to the next index, because here maybe the count was at index 1. Index 1 represents the distance 1. So here the distance will increase to 2. So whatever value we received from index 1 or index 2, it has to go to index 2 or 3 respectively. I mean, the distance will increase. That's how it's done.